Hello ladies and gentlemen, for this video we'll be looking into binomial expansion and we'll be mainly using these two formulas here. This is basically your binomial expansion formula and this is your combination formula which we will use in the later part of the video. Now let's look into the first example. For you to expand 2 minus x to the power of 5, all you have to do is simply follow this formula here. This formula is slightly different from the one that you are given in your exam formula sheet, all right? So look at how to use it. First, we're going to use 5c0, okay? And it's going to multiply with 2 to the power of 5 and also negative x to the power of 0. And then from here is basically just ascending order of this and this value and descending order of this value here, which means the next expansion is going to be 5c from 0 to 1, okay? 2 to the power of from 5 to 4 and negative x from 0 to 1. Again, I repeat, it is the ascending value of these two here and the descending of the middle. So it's up, down, up. Okay, and then all the way until you end up with negative x to the power of 5. So I'll show you from here. 5 again increase value, then this one is decrease in value, and lastly this is also increase. Or you can think of it as these two here are going to be the same. Okay, so we're going to speed it up. You will end up with finally in this last expansion here, 5c5, 2 to the power of 0 and negative x to the power of 5. And this is when you know that you've done all your expansion. Okay, from here, just type everything into the calculator. 5c0 is basically 1 times 2 to the power of 5, and this is also just 1. So 2 to the power of 5 is 32. Okay, plus 5c1, which is 5, 2 to the power of 4, which is 16, and this is just negative x, right? Plus 5c2 is 10, 2 to the power of 3 is 8, and negative x squared. Sorry, the square. When you square a negative, it ends up being just positive x squared. Okay, then this is also 10 to the power of 23 is 10, 4, then negative x to the power of 3, you would just get negative x cubed. Okay, plus it with 5c4 is 5, 2, negative x to the power of 4, you will get x to the power of 4 positive. And lastly, 5c5, this is 1, 2 to the power of 0, this is also 1, then times with negative x to the power of 5. From here, all I have to do is simplify everything and changing the symbols where needed. 32, 5 times 16 times negative x, negative 80x, plus 10 times 8 plus 80x squared. Here is 10 times 4 times negative x cubed, negative 40x cubed. This is just plus 10 to the power of x to the power of 4, and plus here is, sorry, minus x to the power of 5. Then you would end, this is your final answer for the expansion here. Okay, let's look at another example. Now, looking at this next question here, the first three terms in the expansion of 1 minus x over 7 to the power of 14 multiplied by 1 minus 2x to the power of 4 can be written as 1 plus ax plus bx squared. So what we need to know is we only want the expansion values up until x to the power of 2. Everything beyond that is irrelevant for us in this question. Let's make the first expansion here. 14c0, 1 minus x to the power of 14, 0 here, plus 14c1, 1 power of 13, negative x over 7 to the power of 1, plus 14c2, 1, 12, negative x over 7 square. All right, simplify this expansion. We should have gotten 1 plus, sorry, this should be minus 14c1, 14 divided by 7, 2x, okay? And lastly here is plus 14c2, 91 divided by 49, 91 divided by 49x squared. I'm going to simplify it to make it turn into 13 over 7. 13 over 7x squared like this, okay? And everything else other than that is irrelevant to us, so we're just not going to expand it, okay? Now, the next one here, expand the other bracket. Expanding this other bracket here, we would have gotten 4c0, bracket 1 to the power of 4, negative 2x to the power of 0, plus 4c1, 1 to the power of 3, negative 2x to the power of 1, plus 4c2, 1 to the power of 2, negative 2x to the power of 2, and everything else after that is irrelevant. So simplifying this is just 1 minus, this should be 4 times negative minus 8x, okay? And then this would have been plus 4c2 is 6 times negative 2 square. All right, this would end up giving us 24x squared, right? So what we're going to do next is we're going to expand the red and the blue together. Expanding the red and the blue, it's going to be purple. So 1 minus 2x plus 13 over 7x squared multiplied with this for the expansion of x squared. Then this will just end up giving us this times this, this times this, and this times this, okay? Is 1 minus 8x plus 24x squared. This times this, this times this, and this times this. You would end up having minus 2x plus 16x squared. And this times this, you would have minus 48x cubed, right? Which means that this actually is irrelevant already. Lastly, the last three expansion here, here, and here. So it's going to be plus 13 over 7x squared minus the irrelevant one, which is actually just 104 over 7x cubed plus 13 times 24, 312 over 7x to the power of 4. So like I mentioned, the question only wants it until x to the power of 2. Everything else other than that will just be irrelevant, okay? From here, we just group up our like terms. 1 minus 8 minus 2x minus 10x, and then 24 plus 16 plus 13 over 7, you would have gotten 41 and 6 over 7x squared. All right, and this is your final answer. 1 minus 10x plus 41 and 6 over 7x squared, where a is negative 10, a is negative 10, and B is 41 and 6 over 7. And that will be done. Looking at the next question here, find the first three terms in the expansion of 4 minus x over 16 to the power of 6. So in this case here, they are only asking us for the first three terms in ascending power of x. Guys, remember, the number independent of x will also mean that it is x to the power of 0. What do I mean by that? Let me just show you first. 6c0, 4 to the power of 6, negative x over 16 to the power of 0, plus 6c1, 4 to the power of 5, negative x over 16 to the power of 1, plus 6c2, 4 to the power of 4, negative x over 16 to the power of 2. Okay, expand this. Actually, here you would have gotten 4 to the power of 6, 4, 0, 9, 6, and x to the power of 0. This still counts, okay? So still counts in your ascending power of x. We just normally do not write x to the power of 0 down. Then this is actually plus 6c1 times 4 to the power of 5. You would have gotten, it's minus, and then divided by 16, you would have gotten 384x. And here is actually 6c2 times 4 to the power of 4 and over 16 square, which will give you 15x squared. And this will be it in ascending power of x. Not to remember that there is x to the power of 0 here that we just do not write. Okay, this is just your final answer, right? Now, these kind of questions will always be related to the next one. Hence, find in the term independent of x in the expansion of this. This is our expansion from question A, and this is the new expansion which we need to find out first. Finding out the expansion here, it is just x minus 1 over x times x minus 1 over x. Don't need to use the binomial method, just can expand it the normal way. X squared minus 1 plus 1 over x squared, right? This is your new expansion, and multiply it together with this expansion here to find the term independent of x. So use a different color here. Multiplied with 4096 minus 384x plus 15x squared. Okay. To find the values that are independent of x, oh, let me just edit this. So negative 1 is negative 2, right? Okay. Independent of x, what you have to do is, if I use this, multiply with anyone here, they will either be x squared, x cubed, and x to the power of 4. So I don't even bother expanding that. Okay. This times this will have a value independent of x. So this will just be negative 8192, right? Yep, 8192. If I expand it with this, I will get a value that is a coefficient of x. If I expand this with this, I'll get a value that has a x squared attached to it, so I don't bother expanding that as well. Next, lastly, we check with this. This times this, it will give me over x squared, so no. This times this, I will get 384 over x, so no, not expanding that. And lastly, this times this, the x squares will cancel off each other to give us just positive 15. Now, after checking all of this one by one, I know that these are the two values that are independent of x. That means they don't have x around them, or you can think of it as x to the power of 0. Solve this here, it is just negative 8177. Okay,